Hello. So in this video, I'm going to discuss about uh, one of the assignment questions that I given you some time back. The question was like this: the subject business economics was taught by two different methods in the two sections of BBA semester. First, the marks scored by the students in NCP 1 or the internal test is provided below with a significance level of 1%. Test whether the result present evidence of a difference in the effectiveness of the method. So this is a typical case of hypothesis test for difference of means assuming equal variance. So a t-test is used in this case assuming equal variance. So how do you test for the assumption of equal variance? So you can calculate the variance for each of the sample set. So you have a sample of 12 students score from each section A and section B. So the variance of the score of the students of section A is 84, and the variance of the score of the students from section B is 68. So the rule of thumb here for equal variance is like this. If you divide the section, so the first variance by the second sample variance, you should not get a value greater than or equal to 2. That means there should not be, the variance should not double. Okay, here this is the result of the division of first sample variance with the second sample variance, and the score is 1.24. So that means you can go ahead with the t test assuming equal variance. Okay, so the null hypothesis here is mu1 is equal to mu2. That means there is no difference in the mean of the population, and the alternative hypothesis is there is significance difference in the there is difference in the means of two population. So I will show you how to perform a t-test for means in Excel. So first you need to go to data analysis, and you have many options under data analysis, and if you go bit at the end of these options, you will find an option t-test to sample assuming equal variances. So click OK. So you will get this window. There you need to select the range of variable 1 and variable 2, and you can provide a hypothesis mean difference if it is available. Otherwise you can keep it blank, and if you're copying the column with labels, you can give a tick mark here, and alpha is nothing but the level of significance, at what level of significance you are testing this hypothesis. You can specify that here, and this is for basically to select the output range. So I will show you one by one. First let us select the sample 1 test score, and second let us select the sample 2 test score. Since we don't have any, the hypothesized mean difference, let us keep it blank. And since I have selected, when I selected this sample range, I have selected even the title. So let's keep a tick mark in the labels, and the alpha, which we are going to test the hypothesis at 1%. So I'm keeping here 0.01. If it is 0.05, you can keep it as 0.05, but in our case it is 0.01, so I'm keeping it as 0.01. So now let's take the place where you want to the output to be reported. So I'm just you can just click on one cell so that your output will come around here, that range. So let's click OK. So this is the t-test result for two sample, uh, assuming equal variances. Okay, so the first uh, row, the result, you have mean for the sample, two samples. The first sample or the first section has a mean score of 85.166, and section B, students average score, the sample students score is 81.75. The same way variance for section A is 83.606, and the variance of section B score is 67.659. So observation, both the sample are with 12 observations, and this is a pooled variance. This is a pooled variance, and since we have kept 0 under the hypothesis mean, you get 0 here, and the degrees of freedom here is 22, right? So uh, since this is a typical case of two-tailed test, okay, two-tailed test, let's ignore these values. This is basically for one-tailed test. Okay, so before coming to that, this is your test statistics. As you can see, the t-test statistics value is 0.96 96, and this is the probability for the critical value. The critical value is reported as 2.8, 2.82, and the probability associated with the critical value is 0.35. Since t-test also t-distribution is also a symmetric distribution, you have a negative version of this value in the left tail, right? So so what is our conclusion here? You have t stat, you have t critical value, and you have probability, and you also have level of significance given. So there are two ways you can make conclusion based on one is based on, of course, the critical value versus test statistics. Another is level of significance versus the probability, exact probability, estimated probability, right? So if according to the first criteria, if the test stat is greater than the critical value, we reject the null hypothesis. So what is the case here? The test statistics is 0.96, however your critical value is 2.82. So your test statistics is basically less than the critical value, so we fail to reject the null. Okay, you can also confirm it with the level of significance versus the estimated probability criteria, where your estimated probability should be less than the level of significance to say that you reject the null hypothesis. Here let's check what is the case. Your level of significance was here probability is 0.35, however your level of significance was 0.01, right? So your estimated probability is of course greater than uh, the level of significance, so you fail to reject the null hypothesis. So basically, there is no difference. That is what we conclude here. There is no difference in the, uh, I mean, in the effectiveness of the different methods that was used to teach two different sections of BBA student of semester one. So you can cross check this with the the result that you obtained, and I hope you also got some idea about how to do a hypothesis test. I mean, especially the t-test for two sample means in Excel. So I will come up with another video on the remaining questions soon.